Start a new project in 3ds Max and verify that your system units are in inches. You can set your display units to the option of your choice or stay with the US standards for this lesson. From the Max Script menu, choose Run Script and load up the script you saved in matchmover. After a moment, a camera and a set of helpers are loaded. The animation length is also adjusted to match the live footage. The track points come in as a helper group named RZ group. If you switch the perspective view to display the new camera, you can already play back the results that are reminiscent of the live camera motion. Go to the Render dialog and set the output size to HDTV. The live footage resolution is 1280 by 720. If you wish, set it to a reduced size of 800 by 450 and close the dialog. In the camera view, press Shift F to display the save frames. Go to the Environment dialog. Click the None button under Environment Map and choose Standard Bitmap. Browse to where the live footage sequence is and select the first image. Ensure the sequence option is enabled and click Open. This creates an image file list, .ifl file, as you click on OK. With the camera view active, press Alt-B and enable Use Environment Background and Display Background. You can now see the live footage in the viewport. Go to various frames of the animation and notice how the grid's perspective matches the live footage. All that's left is to add your CG props and light scenarios. Save your project to the same folder that contains the supplied sports car you downloaded for this lesson. Merge the supplied sports car. Move and rotate it into a convenient spot. This car was built to scale and therefore will integrate well with elements in the live footage. This is courtesy of the coordinate system you set in matchmover and the reference width of 10 feet, 120 inches you established between car slots. Unfortunately, playing back the animation in the viewport doesn't update the background on the fly. As an alternative, you can use the Next Frame button. If you render the scene now, the sports car may render in black. This is because the car materials are based on MR Arc & Design materials, and therefore the mental ray rendering engine has to be used. This is done through the Render Scene dialog. The render shows a perfect perspective match, but the car still seems to float in the scene as shadows are completely missing. To be able to project shadows of CG elements onto an environment background, you need an invisible object that would still catch shadows. In this case, a flat plane representing the ground would do. Go to the Slate Material Editor, and from the Mental Ray material list, drag a matte shadow reflection material into the viewer. Double-click its node to view its properties. Apply the newly created material to the flat plane representing the ground. At this time, the ground renders black. You still need to define your live footage as a camera map background parameter. From the Environment dialog, drag the background map into the viewer as an instance. Double-click its node and notice that it's set to be used as an environment map in screen mode. This is what you need. Link the background map to the camera map background channel of the ground material. Render the scene again. The ground is now invisible but ready to receive shadows from light sources you create. For exterior lighting, you usually use a daylight system, but the daylight system and the matte shadow reflection material don't work well together. Instead, you will use a simple lighting scenario. From the Standard Lights panel, choose the MR area spot. Alternatively, you can use a direct light, but the MR area spot does a better job with soft shadows, area shadows, which is what you need on a cloudy day. Notice that the existing shadows in the live footage, such as those coming from the light pole or from the other cars, are not very crisp. Notice also the direction of the shadows, as you need to emulate that. In the top view, click and drag to position a light in the top right corner that looks upon the center of the scene. In a side view such as front, move the light up so that it's pointing downward at about a 45-degree angle. You can adjust the light's position later as you do your test renders. In the Modify panel, Spotlight Parameters, open up the light cone completely to make sure it covers the whole scene. Render the scene. You can now see the shadows, but they are a little too crisp. In the Area Light Parameters rollout, set the type to disk with a 5-foot radius. Render again and notice the softer shadows that work better with the background. You still need to adjust indirect lighting as the car appears too dark on the camera side. Also, notice that the car in the live footage appears to have two shadows, one coming from the environment light and one caused by the proximity of the car to the ground. Both of these effects can be achieved with ambient occlusion, AO. Create an omnilight anywhere in the top view. In the Advanced Effects rollout, set it to affect ambient lighting only. In the Mental Ray Light Shader rollout, enable this option and specify a light shader based on the Mental Ray Ambient Reflective Occlusion shader. Drag the shader onto the Slate Material Editor, as an instance, and double-click its node to see its properties. Set the maximum distance to 0 to take the whole scene into account. Render again to see the results. The sports car now looks like a part of the environment. If you wish to adjust the shadow intensity, you can do so at the Matte Shadow Reflection Material level. Set it to 0.05 for darker shadows. Feel free to experiment with other values. You can now render the animation to disk by specifying a file name or view the provided end result, pchal.mp4. If you wish to learn more about ambient occlusion, watch the Faking Global Illumination with Ambient Occlusion How-To movie in the Lighting and Rendering section. This concludes this 3-part movie set on mixing CG elements with live video footage. We hope you enjoyed it.